dx yesterday. Pretty easy, right? Easy one to remember. All right, so moving on to another exponential. So like 2 to the x. So use properties of logarithms to show 2 to the x in terms of e to the x, and then find its derivative. All right, so this is more of a kind of like a proof to like show you how to get the derivative for an exponential. All right, so it says use properties of logarithms to kind of work in e to the x. All right, so if I want to use logarithms, I need to kind of take the ln on both sides. So I'm going to take the ln of y and then the ln of 2 to the x, right? Now I need to somehow kind of work in terms of e to the x, right? So now what could I do on both sides if I want to try and work in e to the x? It's really we know that e to the x and ln of x are what to each other? When have you ever heard me say the word complement? Inverses, right? So if I take the e on both sides now, right? What I'm left with is I have y equals, because e and the ln cancel out, I'm left with e to the ln of 2 to the x, right? So what we want is we want to use this on this side, so we don't want to eliminate it for right now, just to come up with the so this cancels that, right? We could cancel that and that there, but again, we want to somehow use the fact that we know what the derivative of e is into using that to come up with the derivative of 2 to the x. All right, so we don't want to eliminate it right now. Here? Yeah, you're raising both sides to e. Right, this is like, when I did that, this is now an exponent. This is now an exponent. Here? Yeah, right here, yeah. Whenever you see that, you can cancel e and the ln. Right. Right, but for right now, we just want to leave it as is. Right, so now when you take the ln of a, say, of a exponential, right? So you have ln of a to the x. What can you do with that exponent? Bring it out front, right? So you can bring that exponent now down. That's a property of logs, right? So now I have y equals e to the x ln of 2. Now, ln of 2 is what? So it's a constant, right? It's just a number. So right, so if ln of 2 is just a constant, I'm going to put the constant in front of the variable, right? Here to here, or here to here. So when you take the ln of exponential, what you can do is you can move the exponent out in front of the ln. So now the ln is really attached with the base of that exponent. So then you have x times ln, whatever that base was, right? So it's the same thing here. So I can take the x and move it down, right? So now you have the ln of 2 times x. All right, what we want to do now is take the derivative of this step here. All right, so I get dy over dx is equal to so we have a e to the blob term, so what would be the derivative of the e part? E to the blob, so you have e to the ln of 2x, right? Times now, what's the derivative of the exponent? Oh, up, right? Sorry. Again, this is a constant, so you have like a constant times x. So when you take its derivative, you're just left with the constant. So you're just left with ln of 2, right? But now, this here, imagine that's like 2x, right? So when you take the derivative of 2x, you're just left with the constant. It's the same thing. ln of 2 is just a constant. All right, now, what is e to the ln of 2 times x the same thing as? So this is working backwards now. So e to the ln 2 times x is the same thing right here, right? And what did we start with? We started with y equals 2 to the x. So that is the same thing as that. So what I can do is I can replace this with what you started with. So you have dy over dx I swear I'm not. Right. Then you have to take the derivative of the exponent. Right? This is your exponent, so you need to take the derivative of that. Right? So we started with y equals e to the x times the ln of 2, right? And we even before that, we started with y equals 2 to the x. So you're just using substitution. So whenever again, you don't really need to remember like this part. This is just showing you how to come up with the derivative of the exponential. So again, we wanted to write 2 to the x in terms of e to the x, right? So you need to somehow incorporate e to the x on both sides, right? So if I can take the e of ln of 2 to the x, right? What you do to one side, you got to do to the other, right? So this is what I'm left with, right? I can move the exponent down, right? And this is now here what I want to take the derivative of. I know that the derivative of e to whatever is that same thing, and then I need to take the derivative of the exponent, right? And this here is just a constant, right? So the derivative of the exponent just becomes the ln of 2. Now this, again, is just you're using substitution, right? So you're kind of like working backwards. So we said that e to the ln of 2 times x is the same thing as y, and you started your original problem with y equals 2 to the x. So you're just like throwing that out, putting that back in, throwing that out, putting 2 to the x back in. Well, you just need to remember this part here. That's the important part, is not know how to do, but like you need to know how to get the derivative, though. That's the rule that you need to remember. Right, so it's the whatever you started with times ln of the base. Hmm? No. No. Yeah. Yeah. Probably next week. Sometime. Maybe Friday. Friday. All right, so the derivative of any exponential is that exponential times the ln of its base. So if I have like 5 to the x, that 5 to the x's derivative would be what? I don't know. I never looked at it that way. I don't think so. I don't think so. Well, it would be 5 to the x times, right, ln of 5. Right? So again, it's the same thing. It's what you started with times the ln of your base. Yeah. Makes you appreciate it more. No. No, these are, b is just like a number. B is a number. Yeah. Well, actually, yeah, you could actually use that because if you were doing e to the x, right, its derivative would be e to the x times the ln of e. And what is the ln of e? 1. So you're just left with e to the x. Now, if you have something that's different in your exponent, right? So if you had, say, 5 to the 2x, right? Your derivative would be 5 to the 2x times the ln of 2, or I'm sorry, 5, times now the derivative of your exponent, which would be what? 2. Right. Yeah, something other than just plain x to the first. Yeah. Okay. So 7 to the negative 3 over x. Now, how can I rewrite negative 3 over x? What is that same thing as? Okay, so when I find its derivative, right, so the 7 to the negative 3 over x part, right, that derivative would be 7 to the negative 3 over x times the ln of the base. Now you have to find the derivative of the exponent, right? So what would that be? 3x to the negative 2. Okay. And then you just have to simplify from there. So what do we got? We got 3 times the ln of 7 over 7 to the 3 over x times x squared. So you get how we rewrote that? Okay. So this part here is just your derivative of your exponential part, and then you have to take the derivative of the exponent, right? So we're taking the derivative of negative 3x to the negative first, right? So you bring down the negative 1, which gives you a positive 3, and then subtract 1, right? So 3 can stay on the top. The ln of 7 can stay on the top. The 7 to the negative 3 divided by x, that's a negative exponent, so I can put it in the denominator. Same thing with x to the negative 2. I can put that in the denominator. Yeah, because the exponent is really just attached to the x term, not the 3 term. If it was say like 3x to the negative 2 like that, then you would put the 3 in the denominator. But since the exponent is attached to just the variable moves down, but the constant doesn't. That would be your answer. Okay. Can you simplify that? Not 1 to the x, but just x, right? So it's, yeah, the e and the ln will cancel each other, and you're just left with the exponent, or what you're taking the ln of. So its derivative would just be 1. All right, letter C. You got to use what rule? Chain rule, right? So got to bring down the exponent first, right? So I have 2 times e to the negative t plus e to the t. Now you got to take the derivative of the inside, right? So what's the derivative of e to the negative t? And e to whatever is that exact same thing times the derivative of the exponent, which would be what? Negative 1, right? So I have negative e to the negative t, right? Because this is, when you take its derivative, it's e to the negative t times negative 1, right? And then derivative of e to the t is just e to the t, right? All right, so you have 2 e to the negative t plus e to the t times, all right, what I want to do is reorder this term here. Right, so I'm going to put e to the t first and then minus e to the negative t. So if you keep going, what you'll see is if you were to say multiply these two factors together, right? You'll notice that if I do e to the negative t times e to the t, what do I get? E to the what? Right, good. E to the 0. And then e to the negative t times negative e to the negative t would be what? So we're just forming. That's what I'm doing. Okay, good. And then e to the t times e to the t. Okay, good. And then e to the t times negative e to the negative t. Right? So that can't, well, that's just 1, right? 1 minus 1, they cancel each other out, right? And then what you're just left with is now e to the 2t minus e to the negative 2t. Yep. I was hoping to make it easier, like when we multiplied. I don't know. I mean, you could leave the order the same, and you would still end up with that when you multiply. Here and here, they're two different exponents. So if this was e to the 2t minus e to the 2t, then yes, yeah. But since it's a different exponent, you can't do that. So you want to leave it as is. All right, letter D. How would you rewrite that? How would you rewrite that equation? And the chain rule, right? So you have x squared times 5 to the, right, you have squared, you've got sine, and then 4x. Just to show the different different functions that you're going to work with. All right, so when you take the derivative of this second term here, you got, exponential, and then you got chain rule, trig, and then more chain rules. I do. All right, so you got derivative of the first times the second. So you got 2x times 5 sine squared of 4x. So I'm just rewriting it like the original problem. So derivative of the first times the second. Plus now first. Now derivative of the second. So take it piece by piece. So derivative of 5 to the exponent would be what? No, just this part here. 5 to the sine squared of 4x times what? We still haven't finished this. So it's the same thing of what you started with times the ln of 5. Right? Well, now we're going to do that. So you got to do outside, work your way outside in. So this is the most outside function. Now we're going to work with the purple part. Right? So I have derivative of that would be 2 times the sine of 4x, right? Now the derivative of sine gives you what? Cosine of 4x, and then the derivative of 4x Okay, so based off all of that, what do we have in common? Like, what can I factor out? 5 sine squared of 4x I can take out. What else can I take? I can take out a 2. What else? 2x, right? So you have a 2 here, and you have an x squared. So you can take one of those x's with it. So you have 2x times 5 sine squared 4x, right? Factor that out, right? So what I'm left with is just 1, right? Because I factored that out, plus I took away one of the x's from here when I factored it out, so I still have 1x left over. I still have ln of 5, right? Yeah. I mean, really, like, if you were doing it on the exam, like, they're going to look for, like, this is going to be, like, 1 point, and then your final answer would be your last point. They don't really care how you get there. So we took the 2 out, right? So we're left with 4 sine of 4x cosine of 4x. Yeah, I can do that. Oh, sorry. There's more we can do with it, but yes. So, right, I took out a 2 and an x, right? So that's 1 less x, and I took out that 2, right? But you still have no, because when you take out the 2 and the x, like, you cancel 1x from there and that 2 from there, and then everything else has to kind of stay the same. Right. So the 4 can come outside with this x that you have left. So 4x times the ln of 5 sine of 4x cosine of 4x. So you did product rule overall, right? Derivative of the first times the second plus the first derivative of the second. So we did the derivative of 5 to the x first, and then you took the derivative of blob squared next, then you took the derivative of sine to the blob, and then the last part was derivative of the blob. Just make it easy to remember. Okay, what's e to the third power? What is that? Which is alright, so when it's derivative of e to the third power times x would be serious. That's a constant. Right? E to the third power is just a constant. So constant times x is just constant. Alright, you just know it. It doesn't have a variable. The derivative of that? Yeah. It doesn't have a variable, so it's just a number. Yeah, e is technically a number. E to the x is a function. Okay, so number 5 goes back to last section. So we're asking the inverse of f at e if f of x is equal to that, and f of 1 is equal to e. All right, so if f has a point at 1 comma e, what will its inverse have a point at? E comma 1, right? So if I'm trying to find the inverse of f at e, it's going to be the same thing as the reciprocal of f prime at what? 1. Right. Yes. Right, so now all I have to do is find f prime of 1. So they give me f of x. So x squared times e to the x, derivative of the first times the second, plus first times the derivative of the second, it's just e to the x. Okay, so that's the first part. Minus now, again, another product rule. So you have 2x times e to the x. So derivative of the first is just 2 times the second, plus the first derivative of the second, and then derivative of 2e to the x is just what? To the x, right? Okay, so simplify. So we got f prime of x. Okay, so I have 2x e to the x minus 2x e to the x. Bye-bye. Then I have, what else do I have? I have negative 2e to the x plus 2e to the x. Bye-bye. And I'm left with x squared e to the x. So f prime of 1 is, right. So, answering our question now, the derivative of the inverse at e is just 1 over e. So you plug in 1 in for x. So you got 1 squared is 1, and then e to the first is just e. Yes. Yeah. So what would you like me to do about that?